Today I am going to introduce a new discipline in computer science that is called data structure and algorithm. Data structure and algorithm, just like any other discipline, for example operating system, computer architecture, programming language, is one of the core computer science subject. The purpose of data structure is to organize the informations so that the retrieval of the information, searching of information, sorting of the informations and producing more informations out of it should be much more efficient. Take example of railway reservation system. In a railway reservation system, we deal with large set of information. For example, we deal with the trains, we deal with passengers, we deal with the train timing, we deal with the different types of classes in the trains and so on. So if I want to computerize the railway reservations, I have to deal with all the information, and those informations are very vast. So the purpose of the data structure will be to introduce large set of tools and technique so that organizations of these informations will be very efficient. If you want to become a good software professional, if you want to write a good quality software, the knowledge of data structure is very much important. You must have heard of that many disasters in industry have taken place because of the small bugs in the software. For example, our own space program, we had a problem with one PSLV satellites. There is a problem with the French Ariane satellites. There was a problem sometimes with the Pentium chip itself. And later on it was found that the problem was related to a small software. So in data structure and algorithm, we will be dealing with large set of tools and techniques so that you must be able to design a good quality software. So the basic objective of our course is to discuss two broad issues. First, I like to discuss about what is computer science, and then I will be talking about problem solving process. So to understand the importance of this subject, you have to understand the role of computer science as well as the role of computer scientist. For example, take example of just see computer science compared to any other discipline. For example, physics, chemistry, mathematics is a very recent discipline, but within a small amount of time it has influenced all our activities, and its proliferations can be seen, its impact can be seen in the proliferations of computers, network of computers, internet, and uses of all types of various software. You have to today everything you do anything and you have to rely upon the software. Let's define what is the computer science. So to understand what is your role, computer science, fundamentally computer science is a science of abstraction. Is a science of abstraction, creating the right model for thinking about a problem, for devising technique to solve it. Problem is basically what we are talking about is writing a problem means not only writing a program. The basic illusions which we have is that one software professional, one thinks that is a good programmer, but what we are talking about is not a programming, is one aspect of it, that is the end part of your game. First thing, you have to devise a good mathematical model, good theoretical model, so that problem can be easily understood, and later on you have to devise a technique to solve these problems. I have used a word called abstraction, and computer science students always fear this word. They always relate abstractions with abstract algebra. So but the purpose of abstraction here is something different, which I am going to discuss now within different slide now. So the purpose of the abstraction is to simplify the complex and detailed real world situation by understandable model, so within which we can solve a problem. So what we are talking about is that when you try to solve a problem, you have to define the different level of abstraction, and the first level of abstraction is to devise a good model so that you can understand a problem and then devise various programming technique to solve these problems. You have to understand what is the role of the computer scientist. You know that for example, take example of other scientists. For example, take example of the physicists. Their role is, their main job is to understand how does universe work. But our role, they don't design a new world, they don't design some new laws. But we as a computer science has to devise a new abstraction for all sort of problems, and later on, so that it can be easily represented by a computer, understood by computers users, and represented and manipulated inside a computers now. So this is the role of computer scientist. Most of the time you are understanding a problem, devising a good abstractions, and later on trying to solve this problem. The word is, let's try to understand the So basic issues what we are talking about in data structures and algorithms. So main issues in data structure and algorithm is to develop a good simplified model for a complex problem and then solve it by using various algorithms and programming techniques. And so we are going to study large set of tools and techniques which will help you to organize the informations so that the searching, sorting and all the operations which we discussed earlier could be done very fast. Let's try to understand what are how many stages we have to go through for solving a problem. So basically what we are talking about is that the second broad objective of my presentation is the problem solving process. This is what you are going to learn in data structure. I told you earlier the data structure and algorithm, you are learning how to devise a model for solving a problem, and later on using a certain programming language you are trying to solve them. So three stages are very important which you have to understand, and now whole presentation is around these three abstractions levels. First is defining a mathematical model, second one what we are calling them defining abstract data types, and third one is data structure. As we go ahead we'll talk about the difference between all these three steps now. For the time being, let's concentrate on how to devise a mathematical model for certain set of problems. Let's try to talk a very common but trivial problem which we always come across in our day-to-day activities. Every university or every college is having one department, so-called students registrations or examination department, which conducts the examination every semester or every year now. They have to deal with a very basic problem. Whenever they conduct examinations, they have to give the time slots for two courses or for any number of courses such a way that there is no common student. So basically what we are talking about is that we must assign course examination to time slots so that two courses may have their examination scheduled in the same time slot only if there is no student taking both. For example, what we are talking about is if a student has opted for two courses, physics and chemistry, then they should not be scheduled in the same time slot. Now this is a problem. Now let's try to attack this problem. How we'll try to solve them? First we have to define a mathematical model. We are not writing a program immediately. You have to try to understand that what could be the best model so that it could be easily represented by a computer, so that the techniques we learned in data structure could be applied so to get the result very fast. Now the first thing, sometimes we don't understand how to solve this problem. It is not very visible that what is the basic techniques and what is the basic tools we should use to solve this problem. One approach to solve this problem is that let's talk about, so first we are talking about the mathematical model now. One approach will be you to draw a circle for each of the courses and draw a line between the two courses if there is a common student. So what we are talking about, we are presenting certain graphical model. One approach will be, so again once let me repeat, is to draw a circle for each courses. Suppose that I am talking about 10 courses, so we have to define 10 different circles, and then we try to connect these two circles if only there is a common student between these two. So we are talking about a graphical model for these courses now. So let's call it course conflicting graph for 5 courses now. So the problem is a university has to organize the examination for 5 courses. One is called management, mathematics, computer science, electronic commerce and physics now. So we have defined a circle or certain diagram symbol we have used. For mathematics we have taken triangle and so on, and then we have connected a line, we will call them edge, only when there is a common student taking both the courses now. So this is my mathematical model. Now what will be our job? The next job will be to find out from this graph all those nodes, the symbol which you have used for presenting these courses, let's call it a node. So now the job will be to find out all these nodes which are independent. So what we are talking about is that given the course conflicting graph, you have to find out maximum independent sets. Now the term is, we will talk about this type of model when we come to a graph theory as we move into data structure course now. So now once a model is there, your job will be to find out those nodes which are independent, which are not directly connected. So all those independent courses, all the independent nodes, will put them in the first time slot, and then we'll remove all those things from the basic diagram or course conflicting graph. Let's see how it will look like now. So this is what we are talking about. We have given you the definitions now, that what is the independent set is a collection of nodes that have no connecting edges within the collections. In terms of the courses, a maximum independent set is any maximum set of courses with no common students. Now this is what my whole algorithms will look like now. Once we have done this one, so what we are trying to do now, from this graph we are finding only those nodes which are independent, not directly connected, and putting them into the same time slot. So what if you look back, and you can see that in time slot 1 we have only 3 courses which are independent, means they are not directly connected. And what we got them in time slot 1, we got electronic commerce, the time and management, and physics. If we refer back to this graph, we will find that these 3 nodes they don't have any common edge. And then once we have picked up those nodes for a particular time slot, we have to remove those nodes from the actual graph. We'll talk about the graph in quite detail. Graph theory is the most important theoretical tool for solving a problem, not only in the data structure and algorithm, but in other disciplines also. For example, in computer network, electrical engineering, lots of problems have been solved through graph theory. So what we got now, that after we removing electronic commerce, management, and physics, we are finding that we have only 2 nodes and only 1 edge. So the line we are calling them edge is a proper computer science terms. So we have only CS and mathematics. Now just look at one thing, that CS and maths can't be scheduled at the same time slot, because there is a student, there is a common student for these 2 courses. Finally, what we got is in time slot 1, 3 subjects. In time slot 2, we have a computer science, and time slot 3 we have a mathematics. Right now, one thing we have noticed, we are not taking help of any programming language, and this is not the intention of a data structure. You have to find a good tool so that problem could be understood by the user. It could be represented easily within the computer, so that operations like searching, sorting could be very fast, and so on. So this is what we got already. So basically what we have got is the first level of abstraction, understanding a problem and representing them through certain mathematical model. Once we have done this one, let's try to, the word I have used indirectly, so-called algorithms. Now algorithm is very important. This course is not only talking about different models, but also talks about large set of algorithms. Let's try to, you as a computer science, as a software professional, you have to understand what is an algorithm, because algorithm you have to design for each set of problems. Now algorithm in this context will be looking like as dividing the what we call them partitions, the whole course among the smallest possible number of time slots. Once we have understood this algorithm, let's first try to define what is an algorithm. Algorithm is a finite sequence of instructions. When you write a program, the number of instructions should not be very infinite, it should be counted. Number one, so the first thing is you have to understand what is called finite sequence of instructions, and each of statements must have a precise meaning, should not be any ambiguity. They must be able to yield to a particular type of value, and then each statement can be solved within finite amount of time and effort. So this is very important. Sometimes, for example, what we are talking about is when you write a program, you have to understand all these factors should be considered while writing a good algorithm. For example, if you have done some basic programming, you sometimes students write statement like this: 10, that is a level number, go to 10. Now what happens, syntactically this is correct, but 10 go to 10 is basically, it will create infinite loop. So the control will not move further backward and forward. So this type of things you should avoid. So you write a program, all your algorithms must have a very precise meaning. There should not be infinite loop. Number of statement also should be very precise, and the computation of each statement should also be finished in finite amount of time. Once we understand what is the algorithm, let's move to second level of abstraction. In first level, what we did, we understood the problem. How we understood the problem? By devising a good mathematical model. in this case, what was my mathematical model? It was a graphic model. And then informally we devise algorithm that we have to remove certain set of independent nodes and so on. And then let's move to the second level of abstraction. All the level of abstractions you have to go through before coming to actual programming. Now second level of abstraction is what we call them ADT. ADT is basically, it gives you modularity in your program. Whenever you write a program, you should not write in a linear fashion. All your programs should be which have modules, so that if there is a problem, you should confine to only these modules, you should not be concerned about any other thing. You might not understand at this stage, but let me refer to what we are talking about. ADT is, for example, if you know C++ programming language, or in C++ programming language, you will be writing lots of classes. So each class is basically one ADT or abstract data type. So the purpose of ADT is to define all the data types which we have come across in the mathematical model, and also all the operations which are going to take place on those data types, put them at one place, so we are calling them, and this will be called an ADT. Right now ADT is not a implementable unit. It is basically independent of any programming language. Again, but ADT is nearer to the actual implementation. But no, even if at second level of abstractions we are not talking about any programming language, tools and techniques, but this level of abstraction simply helps you to localize all the data and operations at one part. Second set of data and operations will be at another part, and so on. So for example, when we come to C++, we'll talk about that how to define ADT. Class is one construct in C++, which will tell you how to define the ADT. In this context, what is my ADT? Each node which we have defined, each diagram which represents a particular thing could be one ADT, and all the operations can be defined as a part of your ADT. So once we have defined the ADT, basically so one way to understand how ADT is different, or second level of abstraction is different from the first level of abstraction, is that ADT is a pseudo language. Is a language very nearer to C and C++ construct. So after you have defined this one, you define this model so that anybody can easily implement them any programming language. And we learn when we come to other programming language, we will tell you how to define the ADT. Now once we have this one, let's move to the last level of abstraction, and that is called data structure. So the difference between the ADT level of abstractions or second level of abstraction and the third level of abstraction is the second level is still independent. We are not talking about any programming language notations, but it is a pseudo language construct, very similar to C and C++ construct. And the last stage, that is called the data structure. So data structure means that you have to implement them using all the whatever ADT you have defined. Now you have to implement them, and that is what we call them data structure. So data structure will contain large set of ADTs, and depending upon what programming language we are talking about, accordingly this ADT will be implemented. So what we are talking about right now is that data structure is basically implementable unit, is dependent upon a particular programming language notations now. But the one thing which I want to bring your attention is that first and second level you are not considering the programming language, and that is our intention, that solving a problem does not mean that you have to know one programming language better. Of course that is very important, but that is the last part of your game. First you have to understand presentations, defining them ADT, defining a modular structure, and then only you have to define a particular data structure. So data structure is just like ADT, but it has to be implemented into certain programming language. So if you want to write a good program, the two things are very important to you. One is the data structure, and second is algorithms. So your program will contain two basic, and this is the objective of our course. We will talk about large set of data structure and algorithms that will make a good reliable software. So algorithm sometimes differs according to what type of data structure you have used, and the data structure we will be talking about arrays, stacks, queues, and they have a different algorithms for searching, sorting, and all other operations. So basically, let me give you one precise definition about a data structure. Data structure is a basically logical arrangement of data elements combined with set of operations. So when we say data structure is a set of elements, basic elements, to be organized in certain fashions and then define various set of operations to be applied on this set of data. Let's take another example called library data structure. Already one example I have taken, that was a railway reservation system. So when you want to develop a good data structure for any organizations or for any type of problem, you have to find out what are the basic elements. In railway reservation, the basic element was trains, number of trains, number of seats available in each train, types of trains, number of stations, the distance between two stations, train timing, and so on. Let's look at another problem so that you understand what is a data structure. Take example of a library. So if I have to computerize the library, again we have to find out what are the basic components. So basic components are books. Then and so book, you have to organize the books such a way that all the informations can be searched very quickly. So books can be organized different way. One way books can be organized by a title, another way it could be organized by subject, and so on. This is the data structure, the data items plus how we are organizing them. Various way I can organize them depending upon what I am looking for. Once we have done this one, then we have to define various set of operations on algorithm. In the railway reservation, what are the operations we define? Issuing a ticket. In library, we are talking about issuing a book. There we are talking about cancellation of ticket. Here we are talking about returning a book. When somebody is returning a book, it has to be updated. What we are calling them, restore a book that is currently returned. Let's have some more operations on the library system. Somebody has to pay a fine for overdue book. You have to sometimes pay if the book has been lost. So this is your data structure. Identify the items and then organize them, these items, different ways depending upon what is your priority, and then define various algorithms for serving those query. So this is what we have. So far we are talking about all these basic steps which you have to go through in solving a problem. And data structure, the purpose of this course is, I told you this is a core computer science subject, so we will deal with large set of objects, large set of data structures and its algorithm. And some of the important data structure and algorithms will be array, list, stack, queue, tree, graph, and different type of sorting algorithms. Even each data structure will have own set of algorithm. So we will talk about, first we will try to talk about, let me very quickly introduce some of this data structure, how to present this data structure, what this data structure is all about, where they are used, and then introduce some of the algorithms which we will be talking about in the subsequent presentations. So let's take example list. List is one set of data, one type of data structure. List, you know that all the time we are talking about lists basically deals with collection of the items. For example, list of the prime numbers, list of even numbers, and so on. And then, so various ways one can implement the linked list. One way we'll learn how to implement linked list is array based. The second way we learn how to implement is called linked list based. So the basic notations to present a array through linked list is what they call it. It's the easiest way to present a link implement a linked list is to use a collection of elements linked through each other. Let me try to explain you. When we are talking about linked list, each element, each node or each cell we are calling them, each element will be represented by each cell. So this element will contain two parts. One will be containing the data and the second will be pointing to the next data. The difference between the list and the array is that all elements in array are organized in sequential manner, but the linked list, sometimes called a data, is a dynamic data structure. All the elements will be not put at one memory locations or at one set of memory locations, consecutive memory location, but they all will be distributed at different places and linked through a pointer. Diagrammatically, it can be represented like this. So we'll talk about how to represent that. Here is a linked list. Is a linked list representations which contains three elements A1, A2, AN, and each element, each cell, we are calling them, contains two components, basic components, and then pointing to the next component which will be pointed to this one. And when we come to the list data structure, we will talk about how important this data structure. Lots of classical problem, sparse matrices, polynomial additions and so on can be easily represented by linked list. Let's see quickly another data structure, that a stack. A stack has very important role. Compiler uses them. Stack is one special kind of a data structure, or we call them a special type of list. Difference is that all the operations it is only from one end or top. So insertions, additions, everything takes place only from the one end. Now that sometimes it's called last in first out data structure. Whatever element you have pushed on the top, you are going to retrieve it first. And you have seen the real life stacks. You go to the library, you have seen stacks of books. You go to the cafeteria, you have seen a stack of plates. You go to the bank, you see a stack of coin. So stack is also logically, stacks is a data structure where all the operations will be taken only from the one end. When we come to the topic data structure course, we will talk about how to use this stack for solving different type of polynomial. You must have worked with calculator, but you don't know that how this calculator calculates certain expression. It is based on stack operations only. The diagrammatic representation of a stack, you see that the first time I push the element, which will be pointed to A, pointed to by top. Second push, again top will point it to that one. If I have to retrieve this one, so I have pushed three elements and top is pointing to the top element. If I have to retrieve, so you have to retrieve again, the first thing it will be retrieved only from the top itself. Queue is another data structure. You know that basically it is very useful data structure. Whenever we want to simulate any behavior of certain things, we have to use a queue type of data structure. You go to railway reservation system, you go to the go to the airport, you have to simulate the formation of certain queues and so on. In that case, queue type of data structure will be used. But the difference between the stack and queue is that here the insertions is taking from one end and deletion is taking from another end, what we are calling them front and rear. This is so sometimes it's called first in first out. This is the basic behavior we use when we stand in a queue for doing any operation. The person who is standing on the queue first, he will be out first. So this is another data structure. Now in this way, this is diagrammatic representation of a queue. You see that we have shown you two pointers, first front and rear. So whenever element will be added to it, rear will be advanced to it, and top, and whenever, so this way I have added three elements. A is always pointing to the first element, the front is always pointing to the A, but the rear is keeps on advancing depending on how many elements have been added to. So if I have to retrieve something, then the retrieval will be only from the front. You just say that I have retrieved A, now front is pointing to B. In a stack data structure, always all the operations is taking place from only one end, and that is being controlled by this one. So this way we have finished the given you the overview of all the data structure, which we will be talking in quite detail and showing various applications of all these data structure. Let me conclude with one thing, that you know that the software development is a most exciting job, and usually most of the openings in industry is only in the software development side, and it's quite challenging job. So if you want to become a good software professional, again you have to learn data structures very well. You have to know all those tools and algorithms very well. And what we discussed today in our presentation is that I gave you various level of abstraction for solving a problem. Language knowledge of course is very important, but what is important is to understand the problem and represent through good mathematical model. In this I took only one example related to the graph theory, and so that the problem could be represented easily, understood by computers, and all the operations could be very fast. So this way I will be concluding them. Next time we'll talk about all these data structures in quite detail. Thank you very much.